welcome to the data analytics story that we have here. We just built an end-to-end system using OpenShift, mobile, 3scale, and Radanalytics in a story that's called the bike sharing story. How many people here go to work biking? Nobody. How many rent their bikes? Nobody. Oh, there you go. Okay. Do you use a scooter? I know. Did you see those people scootering with cars? I don't know how they do it, but anyway. All right, so who are we? I am Joanna Nakfor. I'm a senior technical account manager here at Red Hat. Love writing software and love inventing, so writing patents. How about you guys?
Yeah. Hi, I'm Vinay Balerao. I'm the senior solution architect at Red Hat, focusing on API management. I spend a lot of time working with customer, craft the API strategies. And yeah, I'm a big fan of APIs and Nutella.
And my name is Michael McCune. I'm an engineer at Red Hat. I work on data analytics on top of OpenShift. And I've worked on OpenShift and OpenStack. And I'm a huge fan of the Grateful Dead, so it's awesome to be in San Francisco.
Are you going to like Weezer?
Maybe.
Are you going?
We'll see. If I get a ticket, I'll go.
Anybody going here to Weezer? Only one person. Oh, yay. All right. So how do we start? Agenda. So we're going to talk a little bit first about the use case, the story of renting bikes, and then we'll go into the high-level architecture of our demo, what the system that we put together to just showcase the different systems we have here at Red Hat. And then we're going to have a deep dive into two components of Red Hat. One is 3scale, which is our API gateway, and one is Radanalytics for data analysis and machine learning. And at the end, if you guys are all here, we'll do the demo. And not sure why I do this to myself. So late doing a demo live. Yeah. Next time I'm going to think about it before I sign up for it. But yeah, hopefully everything works. So for thoughts, we're just going to be asking some questions here. I want to know how many people here belong to companies that have mastered data analytics but just started using machine learning for predictions. Do you use Apache? What tool do you use? Cool. All right, do you have questions? Dead zone.
Yeah, how many of you have like API management or looking for API management to have this in-house? Okay, cool. We have a lot of people.
How many are familiar with OpenShift? All right. That's an easy sell here at Summit. And what about Apache Spark? How many, you mentioned it. How many people here are familiar with Spark? Okay, great, a few people. We'll get into a little deeper on some of these topics as we go on here.
All right, so moving on. So the first thing we're going to talk about is our use case that we picked. I think when I first started researching demos, I picked it because there was a lot of open data that you can just download and play around. And that problem, renting bikes that you've seen around the cities, it's solving the last mile problem for people trying to get to work in the cities. You don't want to drive. Walking, if you're far away, it's hard. And then they just introduced renting biking. And you see here, I took this picture yesterday. You see a lot of companies popping up with these stations to rent bikes. And the trend is going towards something called dockless biking. It just started here in the US. See, I took that picture yesterday to Jump. I think it's just so the idea here is that you can take the bike from anywhere and just dump it anywhere. You don't have to have a station. And that comes with a whole different set of problems. But we looked at these use cases and we tried to answer a lot of questions about how do you build the system, what kind of data can you get, how can you make sense out of this data, and we asked a lot of questions. Some of the questions are, for example, if you're manning your system, you want to know where your bikes are to go get them and make sure that they're available. And I think one of the problems that we looked at is to make sure that the stations have bikes in them and are available for people to use. So that if you have an app and you're trying to get to a station, you want to make sure when you get there that there's something for you to rent. And among other questions, what kind of data I can grab? And there's tons of data you can get from the bike, from the person, from the environment around, et cetera. How do you make sense of this data? How do you build your network? Lots of other questions. If you have mobile apps, how are the users using your mobile app? Where are the bike renting location trends? If you open your API for third-party developers, how are they using your API, et cetera? So lots of questions that we tried to answer. We tried to have some information here in this presentation. All right, so moving on. Interesting picture. That's what happens when you have dockless biking, dockless rental bikes. Yeah, this is not people that use the bike, stack them up like this. It's actually people who got mad at other people who laid bikes everywhere, and they just put them in a stack. I thought it was an interesting picture. Anybody notice that baby in the corner? Pretty cool. I'm laughing at it because I remember saying something about that baby, which I'm not going to say right now. Yeah, it reminds me of something. All right, so let's move on. How did we build our demo? Putting it all together in an architecture view. So we started with mobile app. You know, everything starts and ends with mobile, right? Just a little story. I used to teach a class in my master's, a teacher assistant, and it was for freshman kids. It's just introduction to computers. As soon as I walk in the class, the first thing I did is walk to the end of the class, turn around, and see who has their display on. I would say, shut your display off now and listen to me. So anybody who is looking at their phones, just kidding. Yeah, mobile. So mobile phones, we love our mobile phones. I love my phone too. All right, so the first endpoint here is, just to keep you guys awake, I'll just be throwing jokes. The first endpoint is 3scale. That's our API gateway for authentication, data analysis, etc. And that moves it to the next endpoint, which is our Node.js endpoint that's running on our OpenShift cluster. So Node.js app grabs that data and puts it on a database, and the database we decided to use is MongoDB, and that's also containerized on OpenShift. So we got all our data in. Now we have to use that data. So this is where we use Radanalytics, which has the containerized Spark cluster. And we built another app. This time it's written in Python. And that app interacts with the Spark cluster and with the 3scale API. And these two things is what we want to showcase here in this demo, is that we have two options to grab data and do some analysis on it. And that Python, after it gets all this information analysis, puts them in a portal where we draw charts, and we show different analysis. And you'll see all this in the demo at the end. All right, so this is all putting it together. The two systems that we're going to talk about, just as I explained earlier, is the 3scale Red Hat product and the Radanalytics.io. So 3scale, I'll give it to Vinay so he can get a deep dive into 3scale.
Thank you so much, Iyana.
Sure.
So before we deep dive into 3scale and understand how 3scale is used, we need to understand why you need API management and why 3scale is used. So how many of you had this question? So why you need API management? Since I already have this mobile application, I can directly call the Node.js app, and I can do a lot of fancier Radanalytics things, and I can get back the API response, right? So why you need 3scale API management? So in the past, it was just a matter of users and applications accessing the resources. But now, with multiple users accessing multiple resources from multiple devices using multiple applications, it's impossible for an organization to understand who these users are and what are the access controls to these users, how to provide security for these users, and where does API management comes into picture, which helps you with providing the access controls, who the users are, what are the actual access resources they have to access to, and make sure that they are within the rate limits. So you can have the internal teams accessing the APIs, you can have the developers accessing the APIs, and you can have the partners accessing the APIs. So one part is the access control, and the other important part is the security. So as you have an API, that's a naked API, what we call. And when you expose this API either to the external community or the developers, you have to protect this API. So what we have the API security, what we call, and there are three forms of API security that you can apply. One is the app key, that's a single identifier. Other is the app ID and API key, that's a two single identifiers within the request. And the last is the OpenID connect using the OAuth flows. That is a common thing that we see a lot with the customers nowadays who are moving towards more mobile apps and the service-based applications, and which uses the standard OAuth flow, authorization code flow, client credentials flow, and etc. The next is the reporting and the analytics. So as a provider, you need to understand who are these users, what are they accessing, what are the analytics for those applications, what is the health of the APIs, what is the amount of the usage for those APIs. And that's where the analytics come into part. So you get a holistic view of your infrastructure, your APIs, your health, the statistics for all the APIs, as well as the accounts, the developers, the partners who are accessing the APIs. And all the APIs are available to you as an API. So what you can do is you can export the APIs, and you can feed this into your internal system. And that's what we have done in the demo. So we have taken all the data from 3scale, pulled that via an API call, and we have fed that into the Python application. So this is a very high-level architecture about how 3scale fits into any organization. So on the right-hand side, you see there are the API providers. Those are the line of businesses. Those are you as your company, as an organization, who will have the APIs, and they map this to an admin portal, where you have the Swagger. You can pull the Swagger spec to send an API call. You can get the analytics. Then you can get the billing. On the left-hand side are the API consumers who will be accessing your APIs. We have a branded developer portal where they can just come in, create an account, create an application, get an API key, and access an API. And right in the middle sits the API management platform that is 3scale. So we have two components, API Manager and API Gateway. API Manager can be installed on-prem using OpenShift, and it's also available to you as a SaaS-based solution. And API Gateway is the main part, which sits right in your DMZ. And all the requests that the developer app sends, they send to the API Gateway, which communicates to the API Manager asynchronously, and then send this to the Node.js application. That's what we have with the demo. So I'll just spend a few minutes on the API Gateway. So we are using the OpenResty package. It's an open source API gateway built using the Nginx and Lua. And we have added our custom extensions on the Appicast API Gateway. So you can spin as many as gateways you want. They're total free of cost. And this can be deployed within the DMZ itself. The main advantages over here, it's you can deploy this in your private cloud, your public cloud, within the DMZ, or anywhere else you want. It's available to you as a Docker image if you're deploying this on Docker, OpenShift, or native installation. Yeah, so that's more about the API management. I'll hand over to Michael for the rest of the demo. Oh, sorry, Joanna.
All right, so how did we use the 3scale in our demo? I'll go back and show you the portal. So we used, make it a little bigger. So what we used is we used the hosted version of 3scale, hosted by Red Hat, and as a developer, you'll spend a lot of time here in this section. So you create services and you create an app, and here it's called Radanalytics mobile app. And I think the core of this here is the integration part, where you tell, you edit your API cast configuration, and you tell 3scale that you're going to be getting from the mobile a post and get, HTTP post and gets. They're going to be this URL, and I want you to run this method. And then when you're done, you go and you forward the information to the node.js server that's running in OpenShift. And the cool thing about this is that you can actually test it, and if it tests is right, then you're green, you're good to go. Another part that I want to show you here is the analytics part. So as part of 3scale, they do show you a metric analytics on your hits, on your API hits. And this is how ours looks like. I wanted to show you that there's an option to use this, but we actually grabbed that data through the API that's provided and just drew it in a different way. And if you look here, I also want to show you 30 days ago. Actually, 12 months. So if you look here, this is where we downloaded the open data from a company called City Bike in New York. We grabbed around 4K rentals, and we fed them through a script through the system just so we can store them in the database and show you how it passes through the gateway. And another thing that developers is useful that's provided by 3scale is the API docs. If you want to use their API, it's really simple. It's a very good portal where you can test your API. You can put in the fields here, test your API, and it will give you the JSON, return JSON, so you can see how it looks, and it will also give you the HTTP that you need to build for you to access that. Make it a little smaller. So I used this, application usage by metrics, which you will see in the demo. All right, so that's it for using 3scale. Going back to the presentation. All right, Michael.
All right, so we saw some examples of the analytics that were in use by 3scale, and that was API analytics. Now let's look at another layer of analytics, actually analyzing the data that's being collected by the application. And so Joanna decided to use the Radanalytics.io community project to help deploy Spark and use that as a platform for analyzing that. So I I'm going to talk a little bit about what Radanalytics is and what you might be able to get out of it. So essentially, we are an open source community. We're made up of technologists and data scientists and software developers who are all interested in empowering and enabling intelligent applications on top of OpenShift. And the way that we've been doing that is by creating open source projects that you can use with OpenShift to deploy these frameworks and to get a better integration between your applications and something like Apache Spark. Now, the project that was ended up used for this demo is called Project Oshinko. And this is our tooling around deploying and managing Apache Spark on top of OpenShift. You can use it through the command line or through a browser interface that's deployed into OpenShift. And alternatively, we have source-to-image tooling as well that will automatically deploy clusters for you and then bind them to your applications. So this is kind of a basic architectural overview of what Oshinko looks like. You know, at the base layer, we've got OpenShift as our platform. And then on top of that, there's a little bit of Radanalytics tooling that lives in OpenShift. And that allows you to deploy Apache Spark and to manage those clusters, which in turn, your application will talk to. I'm going to dive a little bit into Spark, and I know a couple of you raised your hands about Spark, but this is what a Spark application looks like from kind of an architectural view. We have something we call the driver process, which is where your business logic lives. It's where your user code lives. And then Spark deploys what are known as executors. And executors are where the distributed processing happens for you. So you can see my user code will create a Spark session, and through that session, I can distribute tasks to be done on the executors. And this happens, you know, seamlessly through Spark. Now at the bottom, I've highlighted the cluster manager here because Spark uses some form of cluster manager to handle the communications and kind of the balancing and everything. Now in our case, we're allowing Oshinko to kind of manage that for us. There are other options that could be explored there as well. This is what it kind of looks like. This is what the Oshinko web UI looks like from an architectural view. So you have an application that gets deployed in a pod in OpenShift. You visit the web page for that application, and then you can deploy Spark clusters through that. You can delete them, you can scale them, you can handle the configurations around them. So really it gives you a full-featured management tool for deploying Spark inside your project. And this is what a version of the web UI looks like. And you can see, you know, I've got a simple deploy button, and then I've got a line for my cluster that's created, the URL to connect to the master. You know, I've got an option to scale it or delete it, and a little bit of information about what its sizing is. There's also a command line tool that gives you the same functionality, but you don't need to deploy that into your project in OpenShift. You simply log in like you would with the OC command, and then you can use the Oshinko CLI tool to perform the same operations, to spawn clusters, to delete them, grow them, shrink them, change their configuration values, you know, anything along those lines. Now, what I find the most interesting, and I think kind of the coolest thing we have, is the source-to-image tooling. And you know, a lot of people raise their hand, they're familiar with OpenShift, so you probably know about source-to-image. It's an easy way to take code directly from your source repository, build it on OpenShift, and then deploy images directly from that. And so what we decided to do as a team was to add an extra layer to this and say, with the Oshinko source-to-image, your application, when it spawns on OpenShift, will create a Spark cluster to go along with it. And that cluster will be bound to your application and your application's lifecycle. So when you get rid of that application, the Spark cluster will then go away. And the source to image right now, we have Java, Python, and Scala. Those are the three most kind of popular supported languages on Spark. And we also have an R source to image that's kind of in the community right now, and it's working its way through. So I invite you to check out radanalytics.io. There's lots of tutorials there and great instructions for how you can take these things and try them out on your own and share them with your colleagues. And with that, I will hand it back to Joanna.
Thank you. All right, so again, how did we use Radanalytics in our demo? I'm just going to revisit the bottom part of the architecture again, just to refresh it a little bit. So we have MongoDB containerized running in OpenShift. That's connected to the Radanalytics Spark cluster through a special connector. And then that's also connected to the Python application that actually can issue commands to the Spark cluster. And they're all containerized running in OpenShift. And then the Python application is going to, just like you're going to see here in a little bit, that is going to also provide a portal where we see all the charts and all the different heat maps and data analytics that we have. All right, so moving on to a couple of lines of code. I know you're going to yawn, but we have to do it. Actually, it's fun to I think code is fun, but I know not a lot of people probably. How many people here are software engineers and write code? Yay. All right, so first thing we do is if you want to use the Radanalytics, you have to, when we built the Python app, we used PySpark. And Radanalytics provides you the template. So we did OC new app, and we picked the template that is provided by Radanalytics. Then we pointed it to the GitHub, and that's the S2I. And then we said our Spark options, we want to use this MongoDB Spark connector here to help us connect to our MongoDB database and read it through Spark. And then we said our cluster name, our Spark cluster name is test. Really cool name. Couldn't be more innovative than this. So after you create your new app, you see in your deployment config, and these are the parameters here, the environment parameters that are pointing to the cluster and showing you that you have used this connector here. We'll use this connector when we're deploying the pod. All right, so the next thing what we did is for you to be able to send commands to Spark, you have to create a Spark session. That's pretty straightforward. We used Spark's session builder, and through the builder we said for reading and writing in database, I want you to use that MongoDB and that collection. We had two collections. I've shown only one here, one for actually all the bike rental data, and one for, we're also getting touch data. Anywhere you touch the display, we feed that back to the back end. That's another collection that we have. So we created the session to Spark. Now we can issue commands. And a lot of the commands that we did is actually just reading the data out of the database and creating data frames. And we used spark.read. And our data frame looks something like this. Again, just as I mentioned before, this data was downloaded from City Bike in New York. It's open data. You can see there's different kinds of information, latitude, longitude, birth year of the person who's renting, start time, end time, start station, end station. And we added the mobile OS there because we wanted to inject more information out of the mobile app. So that's how the data frame looks like. We brought this data frame and we did a lot with it, which I'm not showing here. But eventually what we did is to try to, for the machine learning part, we created a linear regression model. That might not be the optimum way to do it here, but we just wanted to do it as a demo just to show and as an example. And what we wanted to predict is the number of bike rentals within a specific geographic area within a certain time of the day, in the morning, evening, et cetera, and you'll see. All right, so the first step is we created this vector assembler. What this vector assembler does is it reads some of the data and puts it in a feature vector. And that's the feature vector that we want to use as our output column. And it looks something like this. So in the feature vector, we have station ID. Day part integer is just an integer that represents part of the day. Is it the morning, evening, lunchtime, et cetera? The location, latitude, longitude, because we want to get this prediction of rental count, and we are drawing it on a map as a heat map. And then we called it the feature output column. So that's, we did use pipelines, so that's the first part of our pipeline. And you'll see here the next part of our pipeline is actually creating the model, which is a linear regression model. We told the model that our label column is the rental count, and our feature column is the output column. All right, so we created the pipeline. The first thing we did is we divided the data that we downloaded into two sections, one to actually train the model and one to get our predictions. We did not validate the model. I think maybe next time we will. But yeah, so for this little demo, we just did two things. So we grabbed that data, we did a pipeline fit into it, and we have the model now. And the next section is just to do the predictions. And again, the predictions are, so that's the second half of the data model. We did not use the actual numbers of bike rentals, but we used the predicted value. And you'll see in the demo on the map Okay, demo, yay. All right, so, sorry? Yeah, I was going to say that was my other sarcastic comment. Hey, I didn't lose anybody. Maybe we went through too fast. All right, thank you all for staying. So we'll go back to the demo, show you a couple things. The first thing I want to show you is our OpenShift console. Okay, it's readable. MongoDB running in a pod with some storage, not big. And then our Node.js server running in a pod, the Oshinko Web UI also running in a pod. And if we click on the Oshinko, just like Michael showed us, you can control your Spark cluster. Here, you can say create the name test, which we said before, and then you can scale it, you can delete it, you can manipulate it. And then we have the Python application, which is connected, which can issue commands to the Spark cluster. And then right here, you will see that you have the master and the worker for the Spark cluster. So this is how our OpenShift cluster looks like. So let's jump to the portal. And what I'm going to make it a little bigger here. All right. OK, so this is what the Python app gets all this data, does the analysis, and creates these charts for us. The first one that we see here, the API hits data, is all the data that we grabbed from the 3scale gateway. And we just drew a time series and month by month. We saw the labels here. But you can see here, as I pointed out, this is where we actually grabbed the open data and we fed it through the system. And then there, later on, we just did some testing. And then today is May. We have 1919. Who notices something wrong? Nobody's watching. 112 is not 19 plus 19. Yeah, no, that's not a bug. Because it's also counting all the taps that we did on the phone that are also hits on the gateway that we don't show here. So we only show the start rental hits and the drop rental hits. All right, so moving along, the next chart that we have, just make it smaller a little bit because it ate up the chart. All right, so it's more of a business kind of chart, and it's charting, it's a bar chart of number of rentals during different times of the day. And this is a business question, maybe logistic questions of where do I need to put more bikes or hire more people during the day, et cetera. So this data is extracted from the database, pretty simple, just the data of the bike rentals. Next, we have two charts, and they are specific from the mobile. The first one is a pie chart of the operating system that's used by the mobile app. We can see here, this was simulated, not actual data. I don't think Windows exists anymore, but we just made some kind of a skewed, when we generated it, we just made some skewed numbers here to put them. So you have iOS and Android, and another person could be looking at this and trying to figure out, do I put more resources on Android? How do I write my app? Do I write my app only for iOS? Do I use something like Cordova that supports both platforms, et cetera? The next one here is more the mobile heat map is more of a UI UX question, and it will show you, when I run the demo, the taps that users use as a heat map on the display. And this is for UX UI designers to understand how users are interacting with the app. And the last one here that we have is the actual heat map of our rentals. So in this, the way we drew this is we used the predictive rental counts from our linear regression. It's kind of a little hard to see, but let me see. OK, so let's go to the morning. And as we saw earlier in the chart, morning was pretty high. So you can see it's dark, a little darker green, and some purple. But we'll switch here again to the lower, which we saw in the bar chart. It should be evening. And you will see it's a tiny bit little less green. So you can see it's a little lighter green. You probably can't see it very well here, but I can see it pretty clear here on this display. But again, this linear regression model might not be the optimum prediction model for this bike rental. But we just showed an example of how to do the analytics and put them on a map. And think that's it for this part. All right, so we're going to move along here and show you the actual mobile app that we built. Just as a disclaimer, no UX UI designer was involved in this demo. So hopefully you guys like the UI. That doesn't work. I'm going to have to do this again. So 1 second. It didn't work. But yeah, I did tell the immediate family not to text me, but a lot of things are going on. So please turn a blind eye if you see anything. All right, so this is the mobile app. Pretty simple, a bike there, and one button to rent and drop bikes. And we have some bikes here, I guess. Here's one bike. That's our Lego bike. And here's another bike. Who knows what this bike is? Anybody has kids who eat Kinder eggs? No? Well, that's in a Kinder egg. Actually, I had to really convince my kids to borrow it. I don't know why they liked it. But anyway, all right, so we're going to rent a bike, and we have a barcode on these bikes. And let me just make this thing a little straight. The barcode scanner is a little, all right, so. All right. Okay. I think I've done this demo so many times. Okay, let's do it again. Different light, and the paper actually is not very straight, so. And demo gods are not with me today. All right. Whoever wrote that app's not very smart. All right, we'll try this one. Come on, Kinder, you should work. There we go. Well, actually, it didn't work. I think I should have data working here. All right. Doesn't want to do it today. Yeah, it should work both ways. Yeah, we'll try it in a second. Yeah, it still doesn't want to do anything. I think there's like, I have no connectivity because it's not really, yeah. All right, let's try again. Yeah, I have no, yeah, it's not connecting.
Now you get to see some more code here.
If all fails, run Xcode. Okay, this is the last try. I do have a video of it, so if that doesn't work, we'll do the video. How many people here are mobile app developers? Nobody? Oh.
How many people here are mobile app users?
How many get frustrated when the mobile app doesn't work?
That never happens, right?
All right, I'm going to turn that silence thing off, and might that be? Oh. It doesn't want to do it today. All right. think I'm gonna do it one more time and then just show you the video. Untrusted developer. Okay, Apple. All right. So I'm going to play a video that I did before. I knew something was going to happen, so let's play that video.
Chart, we can see all the
We're going to skip through this. Here we go.
bikes and dropping bikes. And we're going to start by renting a bike and hitting the rent bike button. And this will launch our barcode reader. And as you can see, I have a Lego bike. And it has a barcode on it, which I'm going to scan. And the bike number that we're renting today is bike number 18830. So it's saying now I'm renting bike number 18830. So we can drive around with the bike, and then when we're done, we return the bike by hitting the return bike button. And as we do that, you can see that it's saying thank you for renting this. So another day, another time, another bike, we are going to try to rent another bike. So we will hit the rent bike again, and this time we have a different bike. This time we have a blue bike. And we are going to rent this bike by scanning the barcode, and you can see the barcode is 18831. So now it's saying enjoy riding bike number 18831, and we can ride that bike around, and when we are done, we hit the return bike again to return the bike, and we are done. We rented 2 bikes so far, and just for demo purposes, what I'm going to do here, and you can't see it, is I'm going to tap the actual bike icon for 6 times, so we can see the heat map showing that. So we can do 1, 2, 3, 4, 5, 6. Back to our portal, and let's look at the API hits data chart and specifically what happened in the month of May again. And we can see that now we have 7 stop rentals, 7 drop rentals, and a total of 41 total hits. And that again includes all the touch map data that we sent through the gateway. And looking at the mobile heat map, we can also see that our taps or touches were on the rental bike button and on the actual icon that I tapped for 6 times. And I just wanted to see here, you see that the heat map is constant because we are not measuring how hard you tap or whether you swipe or whether you do other gestures on the mobile phone. It's just a constant measure of a single tap. Thank you very much. This concludes our demo.
Okay. So I guess it's good to have plan A and plan B. All right, so that's it for the demo part. We're going to go back to the slides. All right, so all the code is on GitHub, and these are the links to the code. We have the mobile app, the Node.js app, and the Python application. And then lessons learned. Anybody recognize this picture? What are these? They're bikes. They're actually confiscated bikes by the government because they were left in stacks, so they just put them in this. Nobody's coming in and claiming them, so that's where they ended up. So lessons learned, I think building the demo was pretty easy. Putting things together, integrate them is easy, but I think there's tougher questions with regards to how do you make sense of the data? How do you, I mean, we showed you the portal and it has different kinds of data. Not one single user is going to be looking at all this data. I think different kinds of users will be wanting to look at different charts. I think just making sense of the data, knowing, I think I like the order in this picture, and that's how I feel like data should be ordered. But it's unrealistic, it's chaotic. but I think that's the lessons learned. Do you have any comments?
Demos are hard to pull off. That's my loss.
Sorry?
What was the question?
Oh, the links. Oh. All right, and then this is some references too, or final points. So anybody has questions?
Yeah, so the question is, how does Radanalytics relate to Kubeflow? So right now, there really isn't a great deal of overlap between what's happening in Radanalytics and what's happening in Kubeflow. That being said, though, there are members of the Radanalytics community who are working upstream in Kubeflow to help with that project. And also, we'd like to help contribute some of the Spark knowledge that we have there. So at the moment, these projects are a little bit separate, but I think what you'll see is there'll be a lot of collaboration between these projects going forward. So they have a little bit different focus, but at the same time, there's a lot of technology we share. And so we have community members participating there, and hopefully we'd like to bring some of our contributions up to that project as well.
Well, thank you all again for coming in.